which deals with interactive education and popularization of frontal scientific research. We gather active scientists, and therefore, for a couple of days, we offer you the lectures and debates under the project Science Closer to the Society, which is the project co-financed by the Polish Ministry of Science and Higher Education. And the topic of the whole session is extraterrestrial life and civilizations, where and how to search for them. Our session is held in both English and Polish. The English lectures will be translated into Polish and become available in a few days also on our channel on YouTube. I am pleased to announce today that today's lecture, after the lecture on Wednesday by Professor Paul Davies and my lecture yesterday, today the lecture will be given by Professor Joao Magueijo from the Imperial College London, United Kingdom. Hello, Professor Magueijo.
Hi, can you hear me?
Yes, we can hear you. Before we start the proper lecture, I will say a few words about the scientific career of our guests today. Professor João Magueijo was born in Évora, Portugal. So he is a Portuguese origin, working in Britain. He got his PhD in theoretical physics at Cambridge University in 1993. And then he became the research fellow at St. John's College, specializing in early universe cosmology. In 1996, he changed into the Imperial College as first the Royal Society Fellow and then as staff, and he became a full professor there in 2006. Professor Magueijo is working on cosmology, trying to build cosmology on the theories permitting the variation of the fundamental constants in nature, the topic which we already mentioned a few times during our sessions. It's also related to the idea of the multiverse. And in particular, Professor Magueijo was working on the varying speed of light theories. Recently, he has worked on quantum gravity, the biggest challenge of the contemporary theoretical physics, and how cosmology may be used as their test tube, I mean quantum gravity test tube. Professor Magueijo published more than 190 papers. They are very much cited, more than 8,000 times, and cited with the Hirsch index H equals to 42. He also has written two popular books, a travelogue and a novel in cosmology. Last but not least, Joao and me had the pleasure to be the collaborators of late Professor John Barrow from Cambridge University, a renowned cosmologist and an author of the series of popular books in physics and cosmology. We have also met a couple of times, and I think Professor Magueijo also visited once Szczecin for the conference in cosmology. It was, I think, in 2016. Now I would like to give the screen to Professor Magueijo. Joao, please start your lecture about the diversity and inclusion for aliens.
Thank you very much. First of all, apologies for the sunglasses. My eyes are a bit a bit sensitive, so I need to wear them. So this is not a mafia look. There's a good reason for this. I hope you can see me and hear me. Just give me the thumbs up, Marius, please. All good?
Yes, everything is fine.
Okay.
You look as if you were an alien, which is exactly fine, fantastic for the topic. Behind me, we have some pictures made by school students 3 years ago about how they think the aliens look like. So you are quite in a fashion.
Thank you. Well, I'll go straight into my first slide, in fact. So this
Uh,
is not a topic
So,
I
can you initiate the slide, please? Because we stopped them for a while, but you should initiate again. Yeah.
can you see them? Can you see the slides? I was
And not yet. Please click share and
okay. Let's see. I thought you were seeing these already. Uh, okay, sorry about this. Having
uh,
with Wi-Fi.
during this session, I'm using very often the pieces of art which were actually presented by students 3 years ago for our competition on the nicest picture about the shape of aliens in the universe.
So can you see my
Okay.
slide? Can you
Now,
see?
yes, we can see it nicely. Yes.
Okay, okay, all good. Right. So let me go back to the starting point. So indeed, this is what I was saying. Since you already mentioned these pictures, which you ask school children to draw. Well, this is the topic of my talk. I really am going to wonder how prejudiced are we in our perceptions of what alien life might be? So there's always, I can imagine some of the pictures you have are probably not very different from this one. Some probably will be. But there's always this idea of an alien which is basically human with some weird features, like my sunglasses, like a third eye, antennas, etc., etc., etc. So indeed, it's kind of a strange thing that we tend to project our own prejudices, our own views on ourselves into what alien life might be. And of course, alien life might give us a surprise. It might be the case that we're going to have a problem with this. Um, I'm actually not someone who talks about these things very often. I'm going to give you a generic random walk on the various occasions in which I was asked to talk about these and what happened then. But given this is a talk for Polish people mainly, I thought I would start by my favorite science fiction writer, who is Polish, Stanislaw Lem. I have to say I hate science fiction in general. It's not one thing I read very often, but I make exceptions, and Stanislav Lem is one exception, namely because actually some of his work is not really about science fiction, it's really about existentialism, it's about human condition, where we are in the universe. So it's more like using science fiction as a metaphor for some broader issues. And I think it's actually very important to start with one book, and which to my mind is probably his most relevant one, his most interesting one, which is Solaris. So there's actually an object lesson in our prejudices about alien life and our prejudices in general. In this book, by the way, there's a couple of films. I don't recommend the American film. I recommend the Russian Tarkovsky film made from the book. They're completely different. The book and the Tarkovsky film are really completely different. They're loosely based, loosely related. The film is loosely based on the book, but in fact, the final product is completely different. So I have a spoiler alert here. If you want to read the book and not know what's happened in the book, I just switch off now because I'm going to tell you a summary of what happens then in the book. And this is going to be quite important for the point I will make towards the end of my talk. So Solaris is Lem's book, Solaris, is really quite funny on many different levels. And it concerns a planet called Solaris, which orbits a double star. And if you know some basic physics, Newtonian physics even, it just so happens that a system like that, the orbit is unstable. And the observations made, on the other hand, and remember, the book was written way before any extra solar system planets had been observed. But in the book, this kind of sort of science fiction kind of scenario, the astronomers have managed to observe many planets outside the solar system. And in fact, they could map the orbit of Solaris quite carefully and find that, against all predictions of the gravitational theory, the planet's orbit is actually stable. So this leads to a bunch of issues. It's quite funny nowadays. There would be an issue about dark matter versus modified gravity. It's not, it's not part of the plot in the book. Part of the plot in the book is the many theories developed because of this fact that there is this very strange planet out there orbiting a double star with a stable orbit. And if you think a bit about it, you can see that this would be indeed very strange from the point of view, not just of, theories of gravity, which is not an issue in the book, but from the point of view of, what might be happening. I mean, the most obvious explanation is that some intelligent life form is stabilizing the orbit of the planet. But of course, this creates all kinds of problems because the orbit of the planet is unstable on a scale of tens of thousands of years. And if there is an intelligent life form stabilizing the orbit, then, well, according to natural selection, which operates on the scale of millions and billions of years, this doesn't make sense, right? You would never have had time to have a stability in the climate, in the conditions on the planet, for life to have developed according to natural selection. So this creates all kinds of problems. Maybe life came from outside into the planet, but then why did that life settle in a planet which is so difficult to stabilize and have the right conditions for life? So it is a weird problem which is raised by the book. And then what follows is actually funny because it kind of mimics what happens in our society whenever we have a scientific theory. There's waves of interest, waves of an interest. At some point, they nearly fund an expedition to go out there, and the funding gets cut. So there's this kind of typical ebb and flow of interest in science, which every scientist can sympathize with. But the point is that eventually a mission is sent out there. And the first mission goes wrong, so a second mission has to be sent. And eventually they do get there and they find that the planet is covered by an ocean. And there's nothing else. There's nothing special. There's no life forms inside this ocean. There are strange things immediately. There are some islands which form and then disappear on the surface of the planet. But everything looks completely non-unusual, which makes the mystery even worse until something starts to happen, which is that the astronauts start having visions. And the visions tend to be things which go back to traumas, to traumatic incidents in their past, to their subconscious fears. And it turns out the previous mission actually must have encountered something similar. And people even committed suicide or went mad. Things went horribly wrong. So to cut a long story short, and this is very well developed, the book is beautifully developed. At some point, they realize gradually that indeed the planet itself, the ocean and the planet itself is a life form. And that these islands that are forming, for example, are forms of communication, that the visions they have are basically their signals being received and understood by the planet and being sent back to them. So I think the book is wonderful. You can see how Tarkovsky took the book completely in a different direction and took it into issues like, existential nostalgia and so on. But in fact, from the point of view of life in the universe, I think this book is outstanding in the sense that it gives you an idea of how life in the universe could be so completely different from anything we picture, any human thing, any humanizing thing. It's very kind of curious because basically there's a metaphor in the end, which is us trying to communicate with the Solaris planet and vice versa is a bit like an ant trying to communicate with an elephant. There's a difference of scale, there's a difference in presumably intelligence as well. There's a difference in language, a difference in all kinds of problems which create an almost impossibility of communication. Anyway, there's other books by Lem which are even more interesting, like Fiasco is a very interesting book as well, also with this issue about communication. But I think the Solaris one is the one I picked because it's going to be very important for what I have to say towards the end of this talk. So there is clearly a prejudice folded inside our prejudices on the universe in general. Pictures of God, angels, etc. All these things you tend to kind of project ourselves into it. I remember the first time I flew with Alitalia, like back in the 90s. I had this perception that all the air hostesses look like angels. And of course, it's completely stupid. If you start thinking about it, the problem is that our perceptions of angels come mainly from Renaissance painting. Who were the models of Renaissance paintings? Italians. So of course, it's the other way around. There's one of these cause and effect reversal in our prejudices. I mean, not... and in fact, I like this quote. We talked about school children. This is my favorite quote about God, what God looks like, and our Renaissance picture of God. So this kid just said, if God created man in his image, I guess it'd be a black woman, since the first humans were in Africa, but nobody really knows anything about God. So very interesting, and indeed there are problems of perception which go all over the place when we start dealing with these matters and fundamental issues. As I said, I try to avoid these topics because I really don't know much about it, and in fact I've had a chastening experience in the past. But sometimes I cannot avoid it, and this is one example. This must be about 25 years ago. I was invited to a conference which was specifically devoted to life in the universe and how we could have come about, what it would be, etc., etc. So this was in Brioni. Brioni is a beautiful island in the Adriatic, Croatian Adriatic. It was actually the island which General Tito used as a summer resort, used to invite all kinds of heads of state, important people to spend the summer there, and he basically held court, as it were, government from there. So it's a beautiful place to this day. When we went, it was actually quite difficult to gain access to it, but they organized a conference there. And this conference was very interesting because it was, I forgot this story. So I should have said the rooms, all the rooms. There was this hotel, which was basically a very Stalinistic building. And all the rooms are named about people who stayed there. So there's all kinds of important people who stayed in this place. I stayed in the room of where Gino Lollobrigida had stayed. So it was quite interesting to see the kind of people patronize this location. Anyway, as I was saying, this was a very multidisciplinary conference. So life in the universe, how the hell do you speculate about this? And if memory serves me right, there were it sounds like a stupid joke, like a mathematician and a physicist walk into a bar. But there was really like an incredible combination of people there. There was a mathematician, in fact, but if memory serves me right, there was a priest, there was a theologian, two philosophers who couldn't agree with each other, kept arguing with each other. There were two chemists, including the grandson of Arrhenius, the great Arrhenius, one of the first Nobel Prizes in chemistry, and Harry Kroto, actually, who found the fullerene and got a Nobel Prize for it. There were two physicists, a mainstream one and a mad one, which was me. I'll tell you what I did. In fact, some of the talk here is going to be based on that stuff that came out of this conference. There was an astronomer, by the way. This was the time when the first observations about extrasolar planets had come online, and they were still controversial. There was an astrophysicist, two geneticists, evolutionary biologists, etc., etc., etc. So it was quite an incredible array of people. And I must say, if nothing else, even if we didn't conclude much about life in the universe, at least it's funny how aliens brought together such different people from such different walks of science. So very interesting, and in fact, very interesting perspectives. And since I mentioned Arrhenius, why was this grandson doing there? The grandson of Arrhenius was there because actually Arrhenius had been one of the first people to consider panspermia. And so let me give you another spoiler alert and another great book to follow. Fred Hoyle was a cosmologist, probably best known for his steady state universe theory, but he also had a theory about life in the universe. And he also wrote science fiction. And my favorite one is The Black Cloud, which in a way is quite similar to Lam's Solaris, but with slight different slants on the issue. So again, spoiler alert, don't listen to this if you want to read the book and not know the story. But in this case, it's a story of a group of astronomers who discover that there is a black cloud heading for the solar system. Pardon me. Now, this is the kind of thing which nowadays immediately would lead to hysteria in the media, like there's an asteroid heading for the Earth or something like that. I mean, this was a massive black cloud. So are we going to be obscured by the sun? Is the sun going to be obscured by the black cloud? Is life on Earth going to be extinguished by this? Complete panic. And of course, when the cloud gets to the solar system, it just forms an ice disk. Nonetheless, this is Cold War. People are afraid of anything, which is not within their remit, their understanding, their side. So they try to destroy the cloud with nuclear weapons, just to find that the cloud cleverly gets the nuclear weapons and points them back to where they came from exactly. So there is this gradual moment of clarity in which they understand the cloud is actually an intelligent being, except it's a cloud, it's a dust cloud, which is basically just gravity. So how can a dust cloud, completely ruled by nothing to do with chemistry, nothing to do with biological processes, be intelligent? So that is one element of this book, which is quite similar to Solaris, is how things can be so dramatically different. But of course, here there is another issue as well, which is the panspermia issue. Could life in the universe be ubiquitous, be everywhere? So this is the idea of panspermia. And could actually life on Earth have come out from outer space? So the idea of this idea of Arrhenius initially is that natural selection wasn't powerful enough to have generated life if you did some kind of back of the envelope calculation, which might be right, might be wrong, but basically gave the idea that the time scales and the probabilities don't really work out. We need some kind of bump, some kind of boost. And one way this boost could have come out of is actually outer space. So very interesting perspectives came out in this conference. But together with Lam, Hoyle's book really does open up a whole kind of worms. At the lowest level, could life on Earth have come from outer space? But then there is this other issue, which is going to be the main topic later on. Could the universe itself be alive in some form? I mean, not everything is alive inside the living body, but some things are alive, like cells. Could actually the universe itself be seen as a living body? Of course, the devil is in the details. I must say that this is always the problem. It's very easy to sit and have over a beer, watching the Adriatic and come up with these ideas and combinations thereof with such a wonderful group of such different people. The problem is actually making these into mathematical models is not that simple. And I must say this is one of the pitfalls of multidisciplinarity. I actually wrote a paper on evolutionary biology out of this, which is the worst paper I've ever written. Generally speaking, and with notable exceptions, of course, but generally speaking, physicists can be completely naive about biology and vice versa. And this is the problem of our modern life. We're very siloed in our disciplines, and it's very difficult to have any kind of communication between them, which is what you need for a problem like this. But it is actually not an easy thing to do. So let me get back to this issue. So we are clearly incredibly prejudiced in pictures like this one, in what alien life might be. What does this have got to do with physics, though? So why does a theoretical physicist join this melee of questions trying to see whether life in the universe could be completely different? And if you start looking at it, it's like a house of cards. Once you start asking this question, the sky is the limit. So does the life in the universe need to be the result of natural selection? And this kind of clearly sends the problem back into genetics. Does life need to be DNA based or any kind of binary base? Does life need to be carbon based? There are all these ideas about silicon, etc. But does it even need to be chemistry based in the sense we are used to? The black cloud is actually not chemistry based. It's much more complicated, etc., etc., etc. And once you open up this kind of worms, then of course you have to ask the question, does life need to be based on the laws of physics, which we know? So this is actually where I came in. The question is, in a way, a deeper one in terms of foundations of physics. I mean, for the question to make sense, of course, the laws would have to be different, or would have to be different in the sense of multiverse, in the sense of evolution, in some sense, right? So the very first question is, could the laws of physics actually change in time? Now, every time I give a talk to the general public, this is, what's the big deal, right? It's always the question. Look at the Brexit mess, which is befallen the United Kingdom and Europe. So laws do change for humans, so why not the laws of nature, the laws of the universe? And there's all kinds of reasons, and one of them is, to be a bit facetious. Maybe we do expect the physical world to be more intelligent than us. Whatever the case, we do hold the physical laws to a much higher standard than our own laws. And this probably goes back to Aristotelian physics, this distinction between the supralunar world and the sublunar world. One is corruptible, changeable, the other one is immutable. Well, we don't put the division in the sky with the supralunar and sublunar universe, but we do put it in terms of the contents of the universe and the laws of the universe, and the laws of the universe and the laws of humans. So we do make this distinction. So it's not the same. And even in physics, one thing is for the world to change. Just to give you an example, imagine the mass of the Earth changed because of a massive asteroid hit. Quite another is to say that Newton's law of gravity, which rules the motion of the Earth and some of the dynamics, is to say that that would change in such a predicament. If we got hit by an asteroid, our mass would change, our structure would change. The laws which govern the Earth, they will not change themselves. And also, this is not to be confused with evolution within the history of physics, which obviously concerns our understanding of the physical laws, which does change in time, but no one is implying that the laws themselves have changed since the time of Galileo to Einstein. So it's a different perception. In fact, to make this distinction more clear, there's this famous quote by George Orwell: every generation imagines itself to be more intelligent than the one before and wiser than one that comes after. So that's not what I'm talking about. That's basically human wisdom rather than the laws themselves. So this is all stating the obvious, but the point of this preliminary is to drive home the enormity of what we are about to suggest, that the universe could, at least in some extreme circumstances, make it up as it goes along. So this might sound crazy, and in a way it is crazy, but in fact it has a very respectable pedigree. And let me go back to these quotes. I like quotes very much. John Wheeler is behind this idea of the universe came out of higgledy-piggledy. So the famous quote is actually the full quote, was that the universe came into being in a Big Bang, before which Einstein's theory instructs us there was no before. Not only particles and fields of force had to come into being at the Big Bang, but the laws of physics themselves, at least by a process of higgledy-piggledy, as genetic mutation or the second law of thermodynamics. So it's even worse than evolution, right? What John Wheeler is envisaging here is not just evolution, but chaotic evolution and random evolution in a process not that different from genetic mutation, so with an element of arbitrariness and chaos, and with some element of selection, presumably. So it's quite different to say that the universe changed, that there was a Big Bang, that matter had to be created, that matter had to change, that the universe is expanding, is getting colder, and to say that the laws themselves change. And it's quite a big difference. Now, the reason why physicists in general react so strongly to this is what is at stake is really quite stunning. And it is a violation of one of the most sacrosanct principles of physics, the law of conservation of energy. So this is quite difficult to explain if you haven't done the proper physics studies. It's very bad that this is not taught in high school. We teach energy conservation in high school from Newton's laws. So it's a bit of a mystery. You do some calculation, thing comes out conserved. What the hell? What is the origin of this? But in fact, it is equivalent to saying that by changing the laws, you can have a free lunch. But the reason is the following. Better than our high school derivations of energy conservation is this thing called Noether's theorem. So Emmy Noether, a very important mathematician, discovered that there is a very close correlation, I would say, a very close mapping between symmetries in nature, in the laws of nature, important, and conserved quantities. And that's what's called Noether's theorem. So there's like a three-level object here. One is, one thing is to have symmetries in the world, and no one is saying that the world is time translational invariant. Of course, the world changes. But quite another thing is to say that the laws that govern the world changes. That is really quite different. And if the second is true, then there will be conserved quantities, and quantity associated with translational invariance in time is actually energy conservation. So clearly the world can be changing, but there are conserved quantities because the laws themselves don't change. So you can apply this to all kinds of things. Translational invariance gives momentum conservation, etc., etc. But if you ask this question, we know that the universe is changing in time. Could the time invariance of physics itself be broken? You're really asking, according to Noether's theorem, for energy conservation to be violated. Now, this is interesting because, of course, you violate one, you violate the other, but you also end up with a model for creation of the universe, which goes back to John Wheeler's idea that if you actually have this higgledy-piggledy beginning with the universe making it up as it went along, you would also have self-creation of the universe because you'd be violating energy conservation. And this could be the origin of the matter we know, and also matter we cannot see, like dark matter, etc., etc. So very interesting. If the laws change, then what changes about them? That would be the obvious question. And here you have the proverbial Pandora box. Once you allow variability in the laws, there is an embarrassment of riches regarding possibilities. It could be anything, really. So you could have all kinds of changes, some more dramatic, some less dramatic. One in which I have been quite involved with is this issue about the constants of nature. So as an example, consider Newton's law of universal attraction. As you know, this states that the force of gravity is proportional to the product of the masses and inversely proportional to the square of the distance. So there you are. You say proportional. Proportional means there's a proportionality constant, in this case, Newton's gravitational constant, and thus universal constants sneak into the formulation of laws of physics. And as I said, now it could be as dramatic or as less dramatic as you want. For example, you could envisage a theory in which Newton's law of attraction changed from being inversely proportional to the square of the distance to being the cube of the distance or whatever. So this could be quite dramatic. Or it could be something a bit more simplistic, which is to say that, yeah, the Newton's law is actually correct. It's just this proportionality constant, Newton's constant, is not really a constant at all, but it varies. And it could vary in space, could vary in time, could vary with the energy scale with which you do the experiment, etc., etc. So this is the idea of Dirac. This talk is very much rich on quotes, and this is exactly how Dirac also provides some important pedigree to this idea. Let me read the quote. One field of work in which there has been too much speculation is cosmology. There are very few hard facts to go on, but theoretical workers have been busy constructing various models for the universe based on any assumptions that they fancy. These models are probably all wrong. It is usually assumed that the laws of nature have always been the same as they are now. There is no justification for this. The laws may be changing, and in particular quantities which are considered to be constants of nature may be varying with cosmological time. Such variations would completely upset the model makers. So great quote, and I highlight the difference. He does make this distinction between the laws changing in time and the constants of nature changing in time. One thing doesn't imply the other, but there is clearly a connection. And he's basically the forefather of this field called varying constants, which Marius, João Barro, and myself have had some involvement in throughout the years. One thing which is not normally said, this was proposed by Dirac in the 1930s. He wrote the paper during his honeymoon, 1937, in Brighton. The idea was not very well received. Look at what Niels Bohr said. Look at what happens to people when they get married, Niels Bohr. Niels Bohr was, of course, married and had 5 kids, but that's a different matter. So he should know better anyway. So at this point, okay, if we say variability is variability in the constants, then the question that might arise is what constant, which ones? So there's very different types of constants. This is kind of just a small collection of them. You can classify them in different ways. This is just one possibility. So certainly you can see this fact that you have structural constants, for example, Planck's constant, the speed of light, Boltzmann's constant, etc. They're very much constants which are foundational, which really affect the whole scaffolding, the whole basis of physics. And then there's constants which are basically interaction strengths, like Newton's gravitational constant is the strength of gravity. The electric charge is another example. And then there's things which I call descriptive, like the electric mass, the muon mass, etc., the electron mass, etc., etc. You could also divide the constants by dimension full, dimensionless, etc., etc. There's quite a lot of work on this. Now, varying constant theories, precisely because of the different roles the constants play, varying constant theories have very different implications and structures. And for example, a varying G theory, and there's a very classic one, Brans-Dicke theory, 1961, there really is not that controversial. And even the varying E theory is not quite the same. They've now been folded into something called dilaton theories. Well, they're really not that dramatic. They can be dramatic. They can change things dramatically in terms of foundations of physics. You don't have to. In contrast, if you do something, for example, with the speed of light, Planck's constant, etc., then it is really quite a drama. So choosing something like a varying speed of light is more likely to signal actual variability in the laws because you're causing structural damage to the building of physics. And in particular, issues like time evolution, therefore violations of energy conservation, etc., are much more likely in that context, which is probably the reason why when we came up with that idea, including João Barro, believe it or not, we were dubbed by, for example, the New Scientist, as the punk rockers of physics. I can't imagine João Barro being compared to a punk rocker. To which I can only say that the first varying speed of light theory was actually proposed by Einstein himself in the run-up to general relativity, 1911. So ideas are what they are. And what does this imply to our perceptions of what alien life might be? So let me come back full circle. So I started with a few speculations on the problems, on the issues, which I encountered throughout my career, a bit accidentally, and throughout my readings, in the case of Len. And then I'll give you some ideas on how somehow foundations of physics could be part of the issue. So, you know, what is the prejudice we have? We have this prejudice about natural selection, about genetics, about carbon-based life. What about laws of physics? So there is clearly something special about the values of constants we observe. So just to give you an example, I didn't present it before, but you can come up with this dimensionless constant combining the electric charge E, Planck's constant h bar, and the speed of light c. So you make this combination, which is dimensionless, and you end up with this guy being of the order of 1/137. So this is a very specific number. It's not exactly 137, but it's close. And this has been a source of obsession for many people. For example, when Wolfgang Pauli went to hospital for the last time for his bed of death, his unfortunate last visit to the hospital, he insisted on being put in room 137. Such was his obsession with this number. And this number is indeed very special. not only in physics, obviously, but also in terms of the life, of the probability of life. So for example, the hemoglobin molecule would not be stable if alpha were different by more than a few percent, which is remarkable. So this is behind the idea of the entropic principle, which very much underpins Barrow's work in the topic. I don't want to misrepresent anything, and in fact, I don't think I agree with most of it. But the basic idea is that the universe is what it is, so that intelligent life forms and can observe it and wonder about it. And this is kind of a strange way to put things, kind of folding life into the structure of the universe. There really is not just one entropic principle. There's quite a few. There's a range. At the most weak form, this is just a selection principle, like you find in astronomy and astrophysics. So in weak form is basically clearly we're observing, so there must be a selection principle since we're here. It's a conditional probability, if you know statistics. In the strongest forms, this is really quite a strong departure from the way we do science. So this could be even teleological, with causation replaced by towards a name. So the entropic principle is quite a broad set of ideas, which, as I said, is not really one, it's a range of ideas going from one extreme to the other. It folds in with these issues about constants of nature. But the fact is we appear to live on a maximum of the probability distribution of life. So if you change something a little bit and you suddenly get impossibility of life, clearly you're on a maximum of the probability. But could these actually also contain bias and prejudice? And specifically, could it be that this maximum in the probability of life is simply a local maximum? So clearly, this gives you an idea that around the physics we observe, things would be pretty dire for life, but there's no reason why if you went very far away, you wouldn't find other local maxima, which supplied life in a form which is completely different from the one we can envisage with our physics, and which could indeed even happen on different time scales, completely different from ours. Imagine it could happen on the scale of millions of years instead of 100 years, or on the scale of nanoseconds, for example. How would we talk to each other? This would be even worse than the black cloud or the Solaris planet. And also there is a problem with these arguments. For example, what I said about the hemoglobin molecule applies to any relativistic atom or molecule, in fact. So actually gold also would not shine if alpha were different by a few percent, and who cares? So there clearly is some kind of overstatement in the principle when you make these arguments about probability being in a maximum. There is some kind of selection process in working. So this is really where I want to finish. I want to give time for talk, for questions, and I really don't want to extend this to the full 1 hour. But one thing that came up with was this dramatic possibility, right? Could it be that the universe as a whole is alive and has engineered its own conditions for life? So a bit like this planet Solaris, but on a much grander scale. So the planet Solaris is funny because somehow we do not understand it clearly, because the scale is so much different. And it's a bit like trying to get one of our cells to understand the whole human being, right? I mean, we're part of something which is much bigger, which is on a different scale. So it's quite difficult for us to envisage the idea we may just be a micro part of something which itself is alive and which is contributing for the conditions of life, just like the planet Solaris does by stabilizing the orbit around the double star. So I go back to Lem in these final considerations, which are, I must emphasize, highly speculative. It's a crazy speculation, but it amounts to a proactive entropic principle. So not just a selection principle, but actually the fact that we live in a universe with a local high probability of life could have come out from some proactive action from the universe itself. And just like with Solaris, proposing this crazy speculation amounts to an admission of ignorance. A bit like at the end of the book, Lem makes this metaphor of the elephant and the ant. Could they talk to each other? And since we're talking about ignorance, maybe I should leave you with Landau's famous quote. should be careful because cosmologists are often wrong, but seldom in doubt. And with this, I finish. Thank you very much.
Thank you very much, Joao, for this entertaining talk. Okay, a lot of fun I could hear today. In particular, thank you for acknowledging Stanisław Lem, who was really a kind of a hero, a very unique person. But apparently, you know, the communist system finished in Poland and he somehow lost inspiration. So somehow, as he said, it was all this, as he reported one day, all these kind of inspiration for him for writing all those books was coming from some social environment he actually faced under the system. I don't remember, I watched the Tarkovsky film, but I think it fitted to kind of a systems maybe. I don't know, I have to watch. I have one question. Still, we don't have yet questions from the audience. And I would like also to show you, just for fun, some interesting photos, some interesting pieces of art from our competition 3 years ago. So here you see the nice picture made by Bernadetta Bittner, first prize, where you have some kind of what you were talking about, kind of a life which was encycling everything, not necessarily just a form of life, but life which was extended into also some kind of other matter which was in the environment. So you fit with your with your sunglasses very well to the spirit of the whole session. Here is another one which I think you can see now. It's another kind of a picture which was like unifying not only a kind of a, say, alien living, but also its environment. So I'm showing kind of best pieces of art which were sent to us, and they awarded the prizes. So this was third prize by Natasza Ochrońska, who was presenting this. There were also some, this made also some interest among the jury, which is the piece which shows kind of a life which was like also unified with some environment, according to your suggestion related to these living oceans of Lem and its black cloud, etc. So this is also kind of a nice piece. And the last one, which is kind of a, I would say, maybe not so unified, but a bit funny form of life presented on this this piece of art by Natalia Tomala a few years ago. And this time we have also a competition, but the participants are supposed to present the kind of a device to communicate with the aliens. And we are now collecting some pieces of work from them. The final evaluation will be around the 5th of April. Eventually, I may consult you about that if you don't mind. And now, the questions, other questions from YouTube, my colleague can say if he sees anybody is asking on YouTube. Okay, if there are not, I would like to ask one more question about who was the astronomer or astrophysicist during one of this conference you attended, this multidisciplinary conference, who was talking about extrasolar planets? Do you remember the name? No, you.
I'm ashamed to say I actually forgot most of the names, namely the priest. In fact, I mean, I remember the talks. I remember being very impressed by the talks. I remember the contents. I don't remember the names very well. I could probably dig it up if you're interested, but this was indeed a while ago.
Uh-huh. Okay, I'm just asking about some local issues because, in fact, the first discovery was made by somebody who was living actually as a child and a teenager in Szczecin, okay, in Poland. These were the planets which were rotating around the pulsars, not the regular stars. But he was not awarding the Nobel Prize. Some people who were founding these planets around the regular stars were awarding. But I think this was beginning of 90s, I think, this conference, yes. So this was, I think, the time when he was, I mean, presenting this first discovery. That's just the curiosity. Okay, I don't see any questions. Are there any on the YouTube? No, I don't hear anything. So, Joao, today we have English presentation, but it will be translated for the audience who are listening us. Thank you very much for joining us today. As I said, we are having this week the session about extraterrestrial life. We started with the talk by Professor Paul Davies. Yesterday, my talk about the space in general and the space for aliens. Today, as you heard, the talk by Professor Magueijo about integration of aliens. And in 3 hours, we will have also, in 2 hours, in fact, we will have a panel discussion about the astronomical equipment which can be used to detect the signals from the other civilizations. And tomorrow we will have also 2 other sessions about some would-be signals reported from the amateur astronomers, and then the final discussion also. So I would like to thank you very much for the attendance. You were the guests of the Eureka Foundation from Szczecin, Poland, and have a nice afternoon and evening. Thank you very much. Thank you very much, Joao, for you joining us, and hope we will see soon.